Hello and welcome back. In this video we'll take a look at looping, control flow for looping. So the while and the for. So first we need to add a new statement. The while statement. The ordering here is a little bit messed up, but let's put it here. While statement. And a while statement, as we can see here, it should have an expression and a statement. So let's call it condition, which will be an expression, or rather we don't need to box that. And then it will be a statement, which is a box of statement. We'll add another clause to the statement rule that points to the new rule for while. It takes a while keyword followed by. Yes. And not sure why this is highlighted, but the while is the same as the one we have. He calls it body instead. So let's do the same. Okay, now we need to work on the parser. Whoops. Now we need to go here and up here in the statement thing. So we have print left if. Let's now add the while. We don't need that. Then we will just run the while statement. Which we will now implement. And we will consume a left parenthesis. We will get a condition. We will consume a right parenthesis. We will get the body. And we will return a OK of a statement, a while statement with condition and body. So that was easy enough. Except that we need to box this. And then we need to fix the interpreter. So let's see what happens if we get a while statement with a condition and a body. Okay, so let's start by evaluating it. What should we call it? Let's call it flag, because I am out of ideas. Then we have to do this unfortunate RC thing. And then we say, let's make it mutable. And then we can use the Rust while structure to say while flag. Then we need to evaluate the body. Actually, rather, because it's a statement, we need to interpret it. We need to do this weird thing. And then we have to re-evaluate the flag. So first we check if the flag is true. While it's true, we do the body and then we re-evaluate the flag. I think that should be it. Oops. So actually we have to, because this is like a literal value, and also we cannot be sure it's exactly true, so we have to do this. We cannot be sure it's equal to true, we can just be sure it's truthy. We have to, yeah, you get what I mean. Mismatch types. All right, so this one we also need to do that. And in statement, there is now something. Okay. Probably this will remove a couple of warnings. I'm also not going to implement this right now, because evidently it's not really used anyway. So it should probably be removed. Ah. Okay. What? Okay, so let's go into the interpreter, line 74, use of moved value. And is it because it's being used again and again in a loop? We don't have this problem elsewhere. Can we like clone the box and then do it? No. The statement is not clonable. Maybe part of the reason is that we have this weird ownership here. Maybe the interpreter should not take ownership. Maybe we should do something like this. It just has references to statements. Probably this will like break 1,000 things, but line 48. Huh. Or maybe it should be like this. That there is some vector of statements living somewhere and we don't take ownership of that. This will for sure break 1,000 things. But then can we do this? Expected enum statement. That's very interesting. It wants a double unbox. Interpret. Yeah, that broke it a lot. Let's not do that right now. Actually, let me try to fix it, but off screen. Okay, so I've been thinking a little bit about it, and I think I want to make the interpreter interpret a vector which it owns of references to statements. I'm not sure it's possible, but let's try to see if we can make it work. So when I try that, the first error is here in line 48, where it says expected struct vec found a reference to a vect. So we can simply solve that single error with this. It will change the error and it will say that now it's complaining that it expected a reference to a statement, but it got a statement. And the reason is that the block statement type just like has a list of statements. Now we could change that by doing this. This is like effectively a reference, but we don't have to deal with lifetime so much. Well, okay, that didn't work either. The problem is if we do this, it will want us to put a lifetime. Yeah. And I really don't want to do that. So maybe we use boxes instead. And I wonder if it's possible to use a box as a reference. And it looks like it is. You can call as_ref on it. Let's just see if it works. Well, the problem is that now we have this. I mean, we can try like to map all the boxes into as_ref and then collect. I don't think it's gonna work. And we need to like say iter. Well, somehow it worked. At least it's not complaining on that line anymore. So let's go down here. So expected. So here we're giving it the then. So, but it doesn't want a box. It wants a reference. Same here. And the same here. Let's try that. Now we have something in the parser. On line 126. Where it does not like this, so we have to box these guys. That should do it. Then there's something in main where it doesn't. We have a list of statements from the parser. That should be okay. But how do we now turn that into just references? Maybe we do this. So it's like a statement, but then I just want the reference to the statement. I mean, can you do this? It seems impossible. Okay, maybe we can just do this. It's a little bit weird, but if it works. Use of move value statements in the interpreter. So I thought, okay. And this will probably not work either. Well, okay, it did work. So what did we do? I mean, the core thing was that we changed the statements here to the interpret function to be a list of references. So we say like the interpreter should not own these, it should not consume them. They are just living somewhere. And we just look at them and do things with them. We don't change them. We don't free them when we're done. Other people will handle that. And that's kind of necessary because we have this recursive structure where we like call interpret again. So that's a little bit interesting. Let's see if it actually works before we get too excited. Let's try this one actually. Yeah. We can also try the while, I guess. So let's say while A equals A minus 1, print hello from while, and panicked. Could not get mutable. Very interesting. So now we are running into this thing, I bet. In while loop, and let's say before while loop. Just because I still don't have a good debugger for this. And actually, let me make a test folder. Let's call it test cases, because there we may want to make a tests folder with other things. And then I want to go into the test folder, test cases rather, and we'll call this while test. And we want to say define a to be 2. While a, we will say a equals a minus 1, print hello from while, and that's it. So now if I run this, it panics again. Those warnings are so annoying. I really have to fix that. That's interesting. It's not panicking where I thought it would. So let's actually find out where it is. Initializer. Rather not initializer. When defining, print when, well, we know it's not here, but whatever. Evaluating expression. Great. Try that one again. It's not really. It's complaining. Okay, it does say where it's complaining. So environment and line 41. Assign. So where are we calling in assign? Okay, so let me try something. Let me copy this, well, it's just 2, and what happens? Actually, this will probably not go well because what environment are we using here? There's actually, I think that's kind of a bug here because, oh well, maybe not. Because when we evaluate these statements, they will use the, wait, so maybe we should put these into a block. Simply because they need like their local environment. Let's see what he says here actually. Execute. No, he just execute it. I think it could be a bug. So let's do we need to interpret statements in their own block environment? Okay, but it doesn't solve our problem, which is that when we try to interpret it fails. So let me try this. It will run forever, but I should be able to, yeah. So that works. So it is definitely the assignment here. So what could be the problem? What if we change no, stop. A equals a minus 1. Change this to 1. still panics. So what does that mean? It means it's not this thing that's the problem. So let's see what happens. So we go into the while loop, right? Go into the while loop. We call interpret on the statements. The statements are line 3 and 4 on the right. So for the first statement, we will go into expression, I think. Then we will evaluate that. So we evaluate it, it goes in here, it says just to do something stupid, let's see where it actually fails in here. Evaluate it, new value. So it can evaluate the new value. Yeah, okay, we already knew it was in here actually. Environment, assign. So let's go into environment. But the thing is, we do have assignment working in general. So it's just the conflict with the while loop. There's a lot of cloning here, which is not so nice. Okay, so match old value. Huh. Wait a second. Why is it hitting this one? Old value, self.values. Because we shouldn't call this one, we should actually call that one. Okay, nice bug. I didn't like that. Not sure what to do here. So annoying that you cannot call this. Let me try a quick fix here. We'll make a function that we call mutable get, and it will take a mutable reference, but otherwise it will do exactly the same. We will try to call that here and see if that compiles at all. It does not, because but shouldn't it see that this mutable borrow only lives here? Guess not. We can do something like this. Okay. Let's see, line 54. Expected enum. Okay, so let's call it get value. Cannot borrow self, the closing this mutable as is also borrowed as right. So will you let me do this? No. This should not work, but let's try it. Yeah. You know what? Let's do something else. Values.get. Okay, so if there is a value in this environment, then we will just insert the new value there. Okay, if there's no value in this environment, then we actually need to try to get from the enclosing. And enclosing value is well, wait a second. So we are already calling assign on that, so that will try to get a value from itself. And damn, okay, so actually I confused myself, and there's no bug here with that. But okay, let's see if it's the first call to assign, or it's like a subsequent call. So it is the first call that gives the problem. But the weird part is, why is it even going here? Like, yeah, it shouldn't go there, should it? So clearly I'm not understanding my own code. Let's see, while statement condition body is a statement. Because when we go in and pass the body, it's already like discovering that it's a block. So it is wrapping it in a block. So let's go into the interpreter and remove this to do. And let's see. So we check, do we have an enclosing environment? We do have one. We do this clone thing. Is that really necessary? Well, it didn't seem like it was necessary, but at least it didn't work. Now that one fails also. So maybe it's just a new bug I introduced. So clearly we need a better test suite. Okay, so here's maybe a clue. This works. You can define a variable. I can say b equals 3, and then I can print it here. But as soon as I try to override it, then you get a panic. So it must be because this thing will also do but it's already in assign. So weird. So let's try cargo run equals 2. Let's try this. So that also doesn't work, but I can print it. So it is the environment. Let's print, but print should use the environment, right? Yeah, it's doing that. So there's something funky going on. Okay, so the problem is, I think I have an idea now. So when we try to evaluate the assignment expression, we go here, we make a mutable reference to the environment. Then when we go into expression and it finds out, oh, it's an assignment, it will take that mutable reference and call assign to it. On it, as I call assign on it. Value, wait, so. Okay, so the problem is that, maybe the problem is that we are referencing a, like we're doing a plus something. What if we, no, we didn't do that. Now I'm just talking crazy. So this one, this line should not do anything crazy. So it will go into evaluate. It will see that it's just a literal, and then that's it. Then we go down here. We will try to assign, and we give the environment, which is already a mutable reference, and then it sees there is an enclosing environment, and it tries to get a mutable reference to that. But somehow there's already a mutable reference to the enclosing environment. So, and it's in any block. It's in any block. So let's see here. We have a mutable reference to self, so does that mean something? So we make a reference counter thing here, interpret the statements, it's an expression, get a mutable reference. Maybe the mutable reference to the environment applies a mutable reference to the enclosing. Can we? I mean, we probably can't, but and we get comma. Yeah. So we need to do this get mutable reference. Okay, believe it or not, I managed to fix it. And it's a very rusty solution. So it's not enough just to use Rc. We need to use RefCell as well when we want to mutate things. And basically then you use this pattern where you have an Rc to a RefCell, which has the environment, and then you, whenever you need to mutate what's inside the, whenever you need to, let me fix this, whenever you need to mutate what's inside the RefCell, you say borrow mutably, like this, and then you call whatever you want on it. And if you need to do something that's immutable, you just call borrow. And this solved the problem. So I'm not entirely sure why this is necessary, but I think I will read up on that and do a different video on it. So what I've done in here in the interpreter as well is also to wrap it in a RefCell. And now whenever we call evaluate, I clone the Rc. The Rc is just a reference counter pointer, so cloning that is very cheap. It doesn't clone any data, anything, just clones the pointer. Perhaps I could get around that with just giving a reference. I'm not completely sure about that, but for now we just clone everything. And also in expression here, it now also takes a Rc RefCell. We clone things when we pass the Rc pointer on, and we borrow mutably when we need to. So this will fail if we accidentally have two mutable borrows alive at the same time, but we know we won't have that. Anyway, so if we run the while test now, it runs as we would expect, prints two whiles. We can also run the block test, and now the block test works. We can also just test it manually. And if we print A again, it's correctly reassigned. And we should also be able to do this kind of thing, where it prints 5, but then if we print A, it's still 3. Okay, so this was a bit of a long video, but what did we learn? When we have to have some object that has multiple owners that all want to modify it, we really need this Rc RefCell pattern. We cannot get away with just Rc. So that's it for this time. See you in another video.